Good morning, parents and students. This exercise, we did one on arrays, very large arrays, in which we section off sections of hundreds and tens and ones to come up with the product of how many units might be in that particular array. We're going to get even larger. So this is very large arrays. And I think on the worksheet it says very, very, in the thousands. So our answers can be in the tens of thousands. And we're going to take all the experience that we've had in math so far and apply it to calculating these very large arrays. If you do follow the instructions and pay attention, you're going to find out it to be very simple. Give it your best shot. Last week we had arrays that were just single-digit rows and columns. But what happens when you have like rows and columns? Well, we're going to keep our rows pretty small, but what if our columns are like in the thousands? We cannot use a dot for 1,000 of something. It would fill the whole page. And you'd be counting forever, and you'd be saying, there's got to be an easier way. So the easier way we're going to use is some of the math that you've already learned, and we're going to start thinking of arrays in tens of thousands of dots, but we're going to not use the dots. So welcome to week 14. Let's go ahead and read what we have in our worksheet here. This model represents arrays of units for very large numbers. How should we approach very, very large arrays? Now, I gave you a very large array on your worksheets, and you made rectangles and squares and collected all the dots into units of hundreds, tens, and ones. You're going to, let me keep on reading from this. You will see familiar methods for calculating large arrays. For example, how much corn is there in the field? If you went out to Farmington and you saw some of those cornfields, there's tens of thousands of pieces of corn out there. How is the farmer ever going to calculate his yield? Particularly the distributive property. So we're going to use the distributive property here. But remember, these are still units of something. This is very important to remember. We're still going to fill in some units here. Think of very big units when you calculate the products. Use the blank spaces of the paper to show all your work. So over here and under here, if you like, you can show your work. So I'm going to go ahead and use corn. I'm going to say this is corn in a field. And let's say this is the number of the columns, and this is the number of the rows. So we're just going to figure out 2 rows of corn, but there's a lot of corn in just 2 rows. So we're going to use a distributive property, and we're going to break this up into its base 10 components, its place values. So this 1,000 we're going to use for this space over here. So this becomes 1,000. Now remember, in distributive property, we're adding these together, so this top part up here on the outside is going to equal the same amount here. So this sum has to be this. So what would this next box be if this box is the 1,000th box? This box would be what? Be 300. And this box would be the tens box, and this box would be the ones box. So we have 1,000, we have 3 hundreds, we have 60 tens or 6 tens, and 4 ones. And we're going to multiply that by 2. Now this should look very familiar except for the thousands. This should look very familiar because this is the distributive property. We could have 2 times 1,000 here, plus 2 times 300 here, plus 2 times 60 here, plus 2 times 4 here, and that will give us our answer. The only thing that's different is that we're counting units of corn using multiplication instead of counting them individually like we did with dots. So this is much more abstract than what we had before. Remember we used that word concrete and abstract? So now we're going to an abstract model to calculate very large arrays. So let's just go ahead and do this. In here is going to be your product, just like you would when we're calculating areas. So I'm hoping you're seeing a lot of familiarity with the math we're doing. So let's go ahead and calculate the product here. 2 times 1,000. You can even put the x up here if you wanted to. I don't really like doing that for arrays. I like to keep it kind of consistent. But, you know, this is really not an area model, but you could kind of think of it like that if you wanted to. 2 times 1,000 is 2,000. That was not difficult. I have 3 zeros here in the thousands place and 3 zeros up here. 2 times 3 in the hundreds place is 6, and I have 2 zeros in the hundreds place, so I'm going to have to include them. 2 times 6 here is 12. Now, even though we went into the tens place with the 1 here, we have to include what in the tens place? We have to include 1 0, because here's the 0 in the tens place. That's the base 10. And 2 times 4 is 8. We don't have any zeros in the ones place, so we just keep that, a simple 8. So we're adding each of these together. So every time you see something connected like this, we're adding it together, just like you did with your arrays when you made your rectangles and your squares. They're all connected to each other, and that symbolizes addition. So we have to add all this up. Now you might be able to do this in your head, but I'm going to use a space over here and just add up 1,000, 300, 60, and 4. Okay, so I'm just going to add those up. That was very easy also, because there was all these zeros, which doesn't change the value of this 4 or the 6 or the 3 at all. So I have 1,364. Did you guys catch my mistake? I was adding this outside. That's the same number as here. Mr. Budinger, what are you doing? We already know that number. I think I'm still suffering from Christmas. If you guys were following me, I apologize. You probably thought, Mr. Budinger, what are you doing? But I make mistakes too. We're trying to find the product, so we have to add these up. So I have 2,000 over here. We have 600 here. And noticing I'm putting everything in the hundreds, tens, and ones, and thousands place. We have 120 here, even though it's in the tens place. Okay, we have to include that 0. Some of you make a mistake right here in the tens place. This is a very common mistake. You have to include that 0. And let's put the 8 over here in the ones place. So let's all add them up again. It's almost as easy. We have 8 because we just have a bunch of zeros, which doesn't change the value. We have 2 because we have just a bunch of zeros that doesn't change the value. We have 6 and 1, that's not a problem. And we have 2 and nothing underneath it to change that value, so that becomes 2. This looks a lot better. To have the same number over here made no sense at all. So my answer, I'm going to leave this as a expression. That was the word I was trying to think of. An expression has no equal sign here. And with an expression, we usually put the product underneath it. Even if we're adding, it'd be the sum down here. If we're subtracting, it'd be the difference. So let's put 2,728. And this rectangle around this lets me know that this is your answer. Because you could put your numbers all over the place. And I'd be absolutely confused. So let's go ahead and just put a box around here for your answers, so I know this is what I should be looking for the final answer on this side of the paper. So does that look familiar? We use 2 as one of our factors and some smaller numbers here. Let's use a little bit bigger number. Let's say we're going to do 5 times And so these are always going this way, if you notice. I'm always putting a smaller number over here. Most of the time you'll see it that way. Let's say 3,640. I'm just coming up with numbers. Where would the 5 go in this expression? The 5 would go here. This is kind of the smaller part, and this part we need to separate into its place values. So if we're going to separate this into the place values, where is this going to go? The 3,000s would go here, because that's what we have in thousands. What would go here? Oh, don't forget our addition sign. The 600 would go here. Our 40 would go here, and our 8 would go here. If you set the problem up like this, even if you aren't doing very well with your skip counting, you can come up with the product of very large numbers. Super easy way of figuring out very large numbers. Now we've got to come up with a unit. In California, where I come from, they have orange groves. They grow oranges in California and in Florida, so they grow that kind of crop near the coast. So I'm going to say this is oranges, or orange trees, let's say, or orange rows, and there's 5 of them, and this is kind of like what we're thinking the yield's going to be for each row. So this would be 5. I would divide this into 5 rows, and this would be the columns. Obviously, we're not going to have 3,000 columns here. The paper's not big enough. Your room is not big enough. The house is not big enough. So that's why we're using this more abstract method for determining arrays. So let's go ahead and do the math. We can go from this side if we want. Let's go from this side. Let's start from the ones and go to the thousands. Here we went from the thousands just because I go from right to left, but let's go from left to right. It makes no difference. 5 times 8. You should know your skip counting, your 5s particularly. That's a second grade standard. 5 times 8 is, if you said 40, you're correct. Again, this looks like it's in the tens place because it has this 0. But it's not really in the tens place because we haven't figured out our tens yet. We have a 0 here, but that's only because 5 times 8 is 40. So we do have to include that here. If you come up with any product here, you have to add this 1 0 to it because it's in the tens place. If you come up with a product here, you have to add these 2 zeros to it. No matter what, just drop them down into the whatever your multiplication comes up with, drop those 2 zeros in. Even if it already has a 0, drop a 0 in there. Same thing for here. Whatever you come up with here, you have to drop these 3 zeros in there. Super important. So 5 times 4 is, look at this, 20. Now that's just this part of it. We have to include this 0 because we're in the tens place. So this is going to be 200. 5 times 6 is 30. But we're in the hundreds place, so we have to include these zeros as well. So it looks like it should be over here. You know, it's the same number actually. But don't be confused by that. Just go ahead and do your multiplication and drop these zeros into that place value. 5 times 3 is 15. And then we're going to put 3 zeros with that. So I hope you're really paying attention to dropping your zeros of place values into each one of these. Okay, so let's go ahead and add these up. I won't make the mistake I made last time. At least not now. And here's 40. I don't even have a ones over here, so that can happen. Don't think that you need an answer over here if this is 0. This is 0. 4, it has zeros above it, so it's just 4. 2 has zeros above it, it's just 2. 3 in the 5 in the thousands place, that's 8. And then we have 1 over here. 18,240. Again, we don't have an equal sign over here, so this is an expression. So I'm going to put a box around my answer so it's clear what my answers are. So this is 18,240 oranges. So this is your sample. Let me put one more down here, and you have a few over here to practice with. Don't forget to come up with your units. Good luck.